This is another video for you fellows on the mole concept, and I'm going to try to show you a little bit of the math that goes behind calculations that the chemist typically does when we're working with the mole. I've left on the whiteboard up here some of the topics that we looked at in an earlier video where we did mass and count and volume, just to compare those. What I have in front of me right now are the bottles that contained the elements. In fact, the picture that you see right here with all the bottles lined up, all of these are atoms, 1 mole of each. And then on the other side, I'll flip this around, these are our compounds, again 1 mole of each. In every container there's 6.02 times 10 to the 23rd particles, and I showed you before that I did not use tweezers to put those in. In fact, that would be impossible. I instead masked the quantities, and so that's what I wanted to show you and focus on today. So let me move this back. I'll take the simple compound of salt and show you an example of that. When I look at the formula for salt, and let me put this against the board up here for you, I find that it's just simply NaCl, which implies, in the subscripts are not written, which implies that we have 1 sodium, 1 chlorine. In order to do my calculation, I use my periodic table, look at the element mass from here, and then put it on my calculation and end up with a series of numbers that I'll eventually add. So I'm looking at sodium, and it reads 22.99. So I'll take 1 times 22.99 grams, and that will be 22.99 when I carry it through. We'll look at chlorine and the sodium chloride. The chlorine is the element. This is 35.45, and there's one of those, 35.45 grams. And there's the 2 components that eventually we can add together. And that's a simple process for us. Use your calculator, use your head. My total mass for sodium is 58.44 grams for 1 mole of it. Now, I'll show you how I'm going to do that with a balance. And let me turn the computer here a little bit so you can see better. Let me get my safety glasses on. I have a little plastic massing pan, and I have a beaker. I'm going to place the beaker on the scale. I'm going to press the tare button so that the beaker's mass disappears. And hopefully we'll be within the range of what the scale can take. Let's get some salt out of here. Our salt is kosher salt, which means it's pure. I'll just dump some into the little plastic pan, and then we can transfer from the pan to the beaker. Now, just to see if I'm close, I've got my beaker sitting on here already. I'm just going to add the pan to this just to see how close we are. Not bad. This is 53.5, so I need just a little bit more salt, and then we'll accurately dispense it. So a little bit more salt goes in. Let me make a comparison to... Okay, and I have more than I actually need. And now what I'm going to do is I'm going to take some of the salt off. I'm going to dump it all into the beaker, and I'll put the beaker back on the scale. I'll dump all of this in. When I put the beaker back on, I'm reading 58.06, which means I need just a little bit more. Some of the salt stayed on the pan. And we'll just tap that. 58.45. 1/100 of a gram away from our calculated value. And so the quantity that I have here is actually 1 mole of table salt. And it gives you an idea how much space that takes up. So we've done our calculation and we've done the massing. I'm going to erase my board and show you another calculation, and then after I do that we'll be finished for the video. So let me stop the video for a little bit. The next compound I want to do for you is a little bit more complex compound. It has parts to it that you haven't seen before. The name of it is copper 2 sulfate penta 5 hydrate. Now when I put all that together, the copper 2 tells me what the charge on the copper is, and I look at a periodic table's chart of ions and I can figure out what the sulfate is. The penta refers to the fact that there are 5 molecules of water, hydrate, that are attached to the compound. Now, to designate the attachment process, the chemist doesn't use a plus sign, he just uses a raised dot. Now, what is the stuff like? Well, here's a bottle of it from our supply. And let me move that around for you. If I look at the label, copper 2 sulfate, and it tells me a lot more information down on the bottom there, including some hazards. I'm going to take a little bit out and put it in a massing pan. A couple crystals. Let me tilt that towards you. Whoops, it'd be better probably if I use a beaker. Let me just dump it into a beaker. So here's my beaker containing some crystals of the copper sulfate, beautiful blue color. And if you look at it, it's dry, but we say that it has water molecules attached to it. Well, they're attached in a attachment that makes the molecule a little bit heavier. So when I calculate my molar mass of this, I have to account for that. Now, I'm going to back my computer up a little bit. Let me show you how the calculations work. I'm going to start off by counting the atoms that I have from the formula. So I got CuSO4 and then 5H2O. So I have 1 times copper. I have 1 sulfur. We have 4 oxygens. And when I look at the water molecule, I have 5 water molecules. So that's in effect saying I have this. Writing water 5 times. If I count up all the hydrogens, 2, 4, 6, 8, 10. 5 times 2, 10. If I count the oxygens, 1, 2, 3, 4, 5. 5 oxygens. So if I just look at the formula, I can figure out how much of each atom that I have. So let's put that down in our list of elements. 10 times hydrogen. And then the 5 times oxygen. I will now go to the periodic table and look up the masses of these. I look at copper. It's 63.54. I'll multiply it by 1. Grams. I look for sulfur, element number 18, and it's 32.08. Grams. Carry that through. Oops. And my oxygen, I have 4 here, I have 5 here. I'm going to keep them separate for the time being. I could put them all together and call it 9, but I'd like to show them in steps or stages here. So I'm going to have 4 times oxygen. That's 15.999 grams. I multiply that by 4, I get 63.996 grams. And then my 10 hydrogens, 10 times 1.008. This one's easy, just move the decimal point. 10.08 grams. And then for my final one, I'm going to multiply 5 times 15.999 again. Grams. And let me just do that one on a calculator just so I get it correct. 79.995. Okay, final step. Take all of these masses, add them together, and that will give me the total mass for a mole of this compound. So I'm going to turn off my computer just for a second here while I do that on my calculator. I added everything up. The total that I get is 249.69 as my mass. 249.69. And then if I compare that to the label on the bottle, and I'll see if I can get this in the same position. You can see that the mass given on the bottle is 249.69. So my calculation that I've done here and added up, it agrees. So let me put my total up here, 249.69. When I add all these together, $249.69 grams. This is the quantity that I will have for 1 mole. Now let's mass it out using our electric scale. Since 249 is a lot of copper sulfate, I'm hoping that the scale has the capacity to hold it all. Sometimes it's right at the edge of what the scale can do. I'm going to first place a styrofoam cup on the balance. Okay, a beaker would hold the capacity, but it'd probably be too heavy. So let me tear that. Okay, the balance is now reading 0. And let's add copper sulfate to our container. We'll add it little by little. I'm dumping it like a spoonful at a time. The mass is going up. We got about 28 grams in now. Go up to 66. I try to be a little bit careful when I'm putting this in, not to disturb it too much. Fortunately, it's crystals, because sometimes the powder that you get will cause you to sneeze. It irritates the nose a little bit. We're up to 121. $165. $199, and we're going to $249. Oh, I thought this was going to happen. We are now at the point where we've gone beyond the capacity of the electric scale, and what I'd have to do at this point is switch to one of the mechanical balances, usually the one that has the greater range and can weigh the whole thing. So I would eventually finish that off. How much do I have in the container right now? You might be able to see a little shadow right here. So this is going to represent our 1 mole of copper sulfate. And if I compare that to the bottle of copper sulfate that I